Hi, my name is Steve Matthews, otherwise known as Teeth of the Lamb, and today is April 8th of 2019. This is going to be a very brief video today, and we're going to talk about parallax, and we're going to apply that to the sun and the moon. We're taught in school that the sun is stationary, the moon is stationary. It takes 27 days or so for it to make one orbit around the Earth. So in an 8-hour day, it's moved very, very little in the sky. And they say the Earth is turning counterclockwise, and it overtakes the moon, which is also moving counterclockwise. So it moves about 5 degrees in the sky per hour. So for all practical purposes, the Earth is the only thing that's moving, and the sun and the moon are stationary. This is what we're taught in school. So the question that arises, if the sun and moon are stationary and the Earth is the only thing that's moving, then what we're seeing when the sun and the moon cross our sky is simply nothing but parallax. As I demonstrated in the short little clip in the very beginning of this video, that parallax is nothing more than when you're moving and you see a distant object such as a mountain, and all of the trees and things that are closer to you appear to be whizzing by. So the distant object appears to be moving much, much slower. And that doesn't work out very well when you apply it to the sun and the moon, because every day that I'm outside, I see the sun overtake the moon. And that doesn't work out right, because what should be happening is the moon should overtake the sun, and we don't see that at all. So the globe's got another problem, and we're going to look at that today. This day, when I got up, I started filming the moon as it rose, and it went up in the sky for a ways, and here come the sun, and it completely overtook the moon. And as you can see, the moon's up in the sky here and the sun is setting. So from a perspective of parallax, I want the boys that have to set down their calculator, and I want them to take a ride with us in the car and see how parallax works. And then I want them to go back in, sit on the couch, and play with their little balls and tell me how this works, and they can use their calculators, why the sun is overtaking the moon from a parallax perspective. And I'll be waiting for their answer. So first, let's look at what a simplified orbital mechanics would look like. This is what we're taught in school. The Earth is rotating counterclockwise, and the sun is stationary, and the moon, for all practical purposes, is stationary as well. So let's take a ride in the car and see how this works. The distant mountains would be the sun, and the trees that are coming by would be the moon. What do you see going on here? What you see is the sun lagging behind, and you would see the moon overtaking the sun. And that's completely opposite of what we actually see in reality. Everybody has been outside and they've seen the moon rise, they've seen the moon being overtaken by the sun and setting. And if you haven't, you need to take another look. I can cut my head out of it.